Section 4.6, Special Factoring. You'll like this section because it will make you fast. Recall the special product a plus b times a minus b equals a squared minus b squared. So a squared minus b squared is called the difference because it's subtraction. The difference of perfect squares. So the difference of perfect squares. So if you have two expressions that are squared, such as 4x squared, which is the quantity 2x squared, 9, that's 3 squared, 25t squared, what's that? That's 5t squared, 1, that's 1 squared, and 49y squared is 7y. So if you have two expressions that are squared, such as those, and you have the difference of those expressions, then it can be factored as a squared minus b squared equals a plus b times a minus b. So that, recognizing that pattern, will make you a very fast factorer. So x squared minus 9, hey, that's x squared minus 7 squared. Once you realize it's the difference of perfect squares, you can recognize that it's x plus 7 times x minus 7. Or, if you want to, you can put the plus 7 first. The negative 7 first. X minus 7 times x plus 7. Either way is fine. It doesn't matter. Y squared minus 100. It's a difference. There's only two terms, and sure enough, this is y squared, and this is 10 squared. So it's y plus 10 times y minus 10. That's cool. I don't even have to think about it. This guy, 4y squared, is 2y quantity squared minus 5 squared. So that's 2y plus 5 times 2y minus 5. Now keep in mind what's happening here is first you get 4y squared, outside minus 10y, inside plus 10y, last minus 25. So the outside and the inside cancel each other out, and you're just left with 4y squared minus 5 squared, 4y squared minus 25. So perfect squares are wonderful to recognize the difference of perfect squares because they are fast. X to the fourth minus 81. There are two terms. This is x squared squared minus 9 squared, the difference of perfect squares. So we have x squared plus 9 times x squared minus 9. Oh, this is tricky because the sum of perfect squares cannot be factored. But what's this? That is the difference of perfect squares. So this is as far as it goes. You can't do anything else with that. But x squared minus 9, x squared minus 3 squared, x plus 3, x minus 3. You have to be careful and make sure that there are not any more things that you can factor. Just because you did the one step doesn't mean you're through. So here are some other special products. We have the quantity a plus b squared. Remember, to square a plus b, you have to write it down twice and FOIL it. So when you do that, you get a squared plus ab, which is 2ab, plus b squared. So that's a special product. If we can recognize that pattern, it can make us faster to factor. And what is the pattern? Well, this is something squared, this is something squared, and this is 2 times the square root of both of those. This one's very similar. Of course, if you're squaring a minus b, you have a minus b times a minus b. A squared minus ab is minus 2ab plus b squared. And once again, the pattern is you have something squared, you have something squared. The middle this time is minus 2 times the square root of the first and last terms. So let's factor this one. It's important to recognize that this is something squared. This is something squared. That's 9 squared. So you have x squared minus 18x plus 9 squared. And this 18 is 2 times 9 times x. It's whatever this is squared and whatever that is squared, and it's 2 times that. So that means that this factors into x minus 9 times x minus 9. You won't always recognize the special products, so you can still do your FOIL factoring and get there. So x squared comes from x times x, plus 81 comes from negative 9 times negative 9. The minus 18 comes from minus 9x minus 9x. So you can still do your FOIL factoring and get there, but if you recognize that it's a special product, it's fast. Here's another special product. Anytime I'm factoring, what I want to do is put the terms in descending order. I want that 20y next and the 100 at the end. Now, that's 10 squared. That's y squared. And this guy is 2 times 10 times y. If we recognize that he has a special product, it's y and y plus 10 plus 10. We can FOIL and come up with the answer, or if we recognize that it's a special product, it's y plus 10 quantity squared. Special products make us faster. So let's factor and see if we can recognize these. 16x squared minus 40x plus 25. Oh, this is a little bit harder because that's the quantity 4x squared, and that's 5 squared. So the question is this 2 times 4x times 5? 8 times 5 is 40. 40x, it sure is. So this is 4x minus 5 squared. Once again, if you don't recognize that, you can FOIL in reverse. You could say, hey, that's 4x, that's 4x. I hope it could be 8x times 2x. It could be 16x times x. Holy moly, you're just getting yourself in all sorts of trouble there. If you recognize that it's this, it's so much faster. Special products enable you to factor faster. Let's go down here. Sorry, I'm making you dizzy here. If you recognize this as 3x quantity squared, and this is 10 squared, and you hope this is 2 times 3x times 10, is it? 2 times 3 is 6 times 10. Yeah, it works. So this is 3x minus 10 squared. You could factor it out using FOIL and come up with this, same thing, but recognizing the special product is so much faster. Look at this one. You know, I don't really like the way this is written. As long as the y term is positive, I'd really rather put it first. You don't have to. You're going to get pretty much the same thing. So this is 7y squared. This is 8 squared. The question is this 2 times 7y times 8? Yeah, it is. So this factors into 7y minus 8 squared. Now, let's talk about this because this is tricky. Suppose I had not written the original problem in descending order. Suppose I'm sitting here looking at this problem and I just don't do that. And I get that this is 8 minus 7y squared. What do you think about that? Is that the same thing? Yeah, it is. Because if you multiply this out, you'll get positive 49y minus 112y plus 64. And if you multiply this guy out, you'll get 64 minus 112y plus 49y squared. It's the same thing. Well, that's interesting. It's the same idea as saying 4 squared is the same thing as saying negative 4 squared. If you take a number and you take its opposite and square them, you get the same thing. And this is 7y minus 8, and its opposite is 8 minus 7y. And so you square either one, you get the same thing. So either one of these answers is correct. We have this answer, correct. This answer, correct. Same thing. And that's all for Special Products, Section 4.6.